In this experiment, solid liquid and liquid-liquid extraction techniques were performed to isolate caffeine from tea leaves. A sublimation technique was also used for the final purification. Caffeine is a nitrogen-containing alkaloid and is used to stimulate the central nervous system. Caffeine is soluble in both hot water and dichloromethane, which allows for the two-step extraction technique. Sodium carbonate was dissolved in the water used to extract the caffeine from the tea leaves. The sodium carbonate deprotonated caffeine and organic acids. This allowed for the dissolving of caffeine in the dichloromethane, but not the carboxylic salts. A distillation flask and condenser were used for the solid liquid extraction. The leaves were heated in the sodium carbonate solution, which allowed the caffeine to dissolve in the aqueous layer. Once filtered from the leaves, the caffeine was extracted from the aqueous layer with dichloromethane. Once the caffeine was extracted from the aqueous layer by the dichloromethane was vaporized, leaving behind 0.0087 grams of crude caffeine from 1.61 grams of tea leaves. A sublimation technique was used to purify the crude sample. The technique utilized high heat and low pressure to sublime the caffeine. This spectra shows the H&MR of the caffeine molecule and 4 peaks for the different proton environments. The shift in the spectra is due to the deshielding caused by the electronegativity of nitrogen. It is easy to see why the D proton has the largest chemical shift. It is attached to a carbon with a double bond and in between 2 nitrogens, making it the most deshielded. There are some basic differences between the caffeine extraction and the eugenol distillation. Aside from the apparatuses used, differences included pressure, heat, and solubility. The eugenol distillation utilized high pressure to lower the boiling points of 2 immiscible liquids and form a murky distillate. Because the caffeine was soluble in both water and dichloromethane, high pressure was not required. Only high temperature and no distillate was formed.